Alright, time for another draftphysics.com, debatephysics.com also. But yes, the debate is not in a useful form in most cases. Rarely there's a comment or some video produced that has some kind of relevance or credibility, but it's all very rare. And so there is really just talking past each other, pretending the counter arguments haven't been made, frankly, is all I see. And no, they just won't even try to provide an explanation. I mean, you can say something like, well, why haven't they done the Eddington experiment from space? There's 400 times better resolution. Not 4, not 40, 400. Yes, much easier to do from space. So you can use Jupiter. You don't have to use the sun, and you still have 300 times better resolution. 300. Anyway, and we're supposed to believe it never occurred to the scientists to do that fundamental experiment. And they don't have a reply of any kind. Nothing. So, it's all kind of... But, unfortunately, I have to get into a subject. I shouldn't even, this shouldn't even be part of the conversation. So, apparently, not only are people who are engaged in this discussion incapable of understanding any physics, they can't even understand basic, simple, ethical things, like, not shitting in somebody's front yard or something. They can't figure this stuff out. And so there's this concept on the internet called doxing. All right, it's where this free speech haters, the people who hate that anybody else would have a different opinion and express their opinion, they will abuse this system, okay, and they will have you swatted. I've been swatted 3 times. No, they didn't pull their guns, but, when the cops show up at your door, making accusations that are completely fallacious, made up, it's not pleasant, especially when you don't like cops. And especially when you're a bit of a dissident, that you piss people off. Just not a good thing. And I don't live in my house anymore, so it's just not about me. It's about other people. So, and they can't figure this out, right? They can't figure out that you don't fuck with this. You don't fuck with somebody's security. Yeah, that's hard to figure out in a free speech environment. I don't use this system to try to drive somebody off the internet. I don't threaten them with, I'm going to report you to Google. I'm going to do this. That's baby. That's the pettiest, lowest brow kind of behavior. And these jackasses endorse this bullshit. And so I've pointed out that Piro, okay, has the name Piro, right? Everybody calls him Piro. We don't worry about what his first name and his last name are, right? Nobody needs to know. Now, he made it public, okay? It is a fact that he linked to his blog in the past. His blog had his name on it. All of that was something he made public. He made it available, quote unquote, okay? But would that give somebody an excuse now to sit there and jeopardize his security by playing with his real name? So if I were to make a Google account and a YouTube account, and all I put up on the YouTube account was information about him and his wife and his son and legitimacy issues and all kinds of stuff, and his daughters, and I could bring up all kinds of stuff about his history on the internet, and that would be, everybody would think I'm a great hero. Everybody would say, great, wow, you really got him good. You really countered his physics arguments with that great personal attack. It's just so ridiculous. So the fact that these morons can't sit there and even figure out that, okay, look, I'm not going to associate myself with people that use those tactics, okay? If those are your tactics, you want to confine somebody's free speech, you want to try to use this system to extort them out of saying anything or doing anything, I'm really not going to associate with you. I'm not going to play with people who use those tactics. All right. They can't even figure that out. So, I mean, they choose to put their name public. That's their business, right? What am I going to say? Sometimes you don't have any choice. You know, there's lots of people that publish papers that do different things, and they're outed, and they don't got much they can do about it. You know, but there's no reason to force everybody to be extorted. And clearly, people who have some sort of fame and all of that kind of stuff have some sort of protection. You know, people who say what the system likes to hear have protection. People who say something the system doesn't like to hear are vulnerable. And if you can't figure that out, I mean, there's literally hundreds of channels now just showing all of the ways in which government employees go after people, you know, because they talked back to a police officer, because they said, I have constitutional rights. I have been, again, this is stuff that are in actual videos where people just keep lying about how I'm on some sort of watch list because I did something wrong. The only thing I did wrong is I told the judge, you're violating my constitutional rights. That was my crime. So let's understand, I got on a watch list because I told the judge, you're violating my constitutional rights. And then I went to a federal appeals court and asked them to stop him from violating my constitutional rights. And guess what? They agreed that he was violating my constitutional rights. Now, I didn't ask them to get me off the watch list. Okay, yeah, I didn't bother them with that subject. But frankly, I was proven, I was exonerated 100%. And these liars will keep trying to imply I'm some sort of terrorist, and I'm some sort of rights violator, and I'm some sort of person invading somebody's privacy, or I'm some kind of person making threats, when none of that's true. And so it's just so dishonest, so despicable that they would resort to these personal attacks. So again, I just asked them the question, is my response that I should do the same thing? That I should respond in kind, and so I should out all the people who I know their real names, that I should jeopardize their security, and I should send my little minions and trolls out to go research them and you know, try to get them extorted off the internet. Yeah, I should threaten their children, their family. Oh, it's so bad. All right, anyway. So why should I even engage in a conversation, right, with morons this stupid? And so that's a question I have to ask myself. And as I've pointed out before, if you want me to completely ignore your channel, then just keep doing it. Keep affiliating yourself with these malicious people, and that's what you'll get as a response from me, because I have nothing else I can do. Okay, there's no other mechanism to force you to be reasonably civil. It just isn't one of the rules that YouTube has. It doesn't have a be reasonably civil rule. All right, so with that context, I'll just say a certain jackass on the internet keeps making pendulum videos, and he won't clean up his comment section, so I will describe his moronic physics, and where he's showing a tremendous lack of aptitude. Now, these are the very people that keep griping about whiteboards, like somehow physics isn't about whiteboards or blackboards, even though it's one of the most, there's probably not more icons with blackboards in them and physics. It probably is the most associated subject with a actual blackboard, or whiteboard in this case. Just another irony that they're using that as an insult or an attack. Oh, he's using a blackboard. What a crazy idea. That's so unscientific. You know, it is really just mockably moronic. All right. So what has been discovered through these experiments and conversations and drawings, okay? I discovered it. Nobody else did. Okay, I explained it. Nobody else did. All right, is in these lever experiments or pendulum experiments, there's always this issue of the mass you're using to launch something. So the maliciously associated moron is doing an experiment with a piece of wood, Okay, and a spring. Okay. So at least it's got the same force part right. Okay, it doesn't have much else right, but yes, apply the same force. And the idea is you're going to launch a pendulum that you can change the weight of. Okay, and you're going to see how far does it go. So I pull it back a fixed amount. Okay, so I apply a fixed amount of force. And now I'm going to hit the object or push it and give it motion. Okay, and I'm going to measure that conversion of the force here into the object and whether or not it produces this kinetic energy effect. Okay, so this will be variable from a 1 mass to a 2 mass. Now the other catch to his experiment is he did this thing, which wasn't too bright, where he actually had the masses on a stick, you know, literally. And so the problem becomes that when the stick is moving at a faster velocity, you could sort of understand that if I move the stick at 1v, this part of the stick is moving 1v. And then if I make this part of the stick move 2v, right, you can understand that that whole stick is now moving faster. So all of the little atoms inside of the stick have to be pushed. So they're consuming part of the energy. They are part of the energy. So if it hits something, they're going to be part of the energy. And if you have to push it, they're part of the energy you have to push, part of the mass you have to push. And obviously going twice as fast means this stick gets 2x the momentum, okay, when it's going twice as fast. It's twice the momentum. Now the issue is well, parts of it are going really fast here, and parts are going pretty slow here at the pivot point, closer to the pivot point. So you could understand that the velocity, the average velocity, would be here in the center of its mass, wherever the center of its mass actually may be. That's the point, okay, where it's the average amount. So you multiply the mass times the average velocity for the thing, and then you can know how much momentum it's adding or subtracting. Well, obviously adding in this case, to the experiment. Now the other problem is this is doing exactly the same thing. This piece of wood has to move. So he's putting the weight, he's not doing the lever experiment. So, you know, we've already done this so many times. So there's different ways you can do this lever experiment. You could drop a weight in, okay, at a location. So here's your fulcrum. And then you can know that, well, here it's going to move the same exact amount, the same speed as here. But if I go twice the distance, okay, it'll move twice the velocity out here. So when this moves 1v, this moves 2v. So you can understand that if I have a 2 mass here, and I put a 1 mass out here, all right, that would be now the twice the velocity. But if I put it here, the whole lever has to move twice the velocity. See, the lever moves the same speed. If I put a 2 mass here, or a 1 mass here, the lever moves the same exact speed. So to do 2 velocity here is the same speed for the whole lever as 1 velocity here. But the fact is if I put both weights here, well, to make this lighter object go twice as fast, the whole lever has to go twice as fast. So the entire mass of the lever now is consuming, okay, a substantial part of this thing's energy. So when this comes in, a big part of its energy is going to be consumed trying to push the lighter object twice the speed. It's going to have to move the lever twice as fast to do that. That means it has to move all the atoms of the lever twice as fast. So obviously it's not going to be able to get all the energy into the object. So there are rules about how you do this experiment. It's just a fact. So, all right, so back to his example. So first off, he didn't quite know how to compensate for this weight thing. He does it, he takes it off, he puts it on, he keeps playing with it. But yes, the idea would be is that you can add the full mass here or half the mass here as a compensation. So you're compensating for the fact that you have, let's say, a stick that weighs 0.5, you have a weight that's 1, and then you have the other weight that's 2. And you want to keep the 2 to 1 relationship. Well, the problem is you have a 1.5 to a 2.5 relationship. And so you've lost your 2 to 1 relationship, so you have to add the extra mass to compensate to the heavy side. So the heavy side needs to have this little extra weight put here. So you either put the full 5.5 here, or you put a 2.5 here at the bottom. But you have to add that extra weight. And then on top of that, and then when you did this, now you have to do the same thing here, because you're not using the lever properly. And even if you used it properly, you'd still have the problem of, well, this does dilute the amount of energy the force can produce. But to do the experiment correctly where this doesn't matter, okay, this substantial weight being pushed by this spring, then you have to put this twice as high up on the lever. You have to put the one mass where it's going to go twice the velocity for the same movement of the lever. So if you want to negate the weight of this lever, you do have to move the weight for the one mass up where it's moved, the lever's moving twice as fast. Then the piece of wood will consume the same amount of force for both actions. This action will be the same amount of momentum in the wood as this action up here, the faster velocity. The two actions will consume exactly the same amount of force. But if you try to do them from the same spot, no, not going to work. Alright, so that's where we are. Just another messy, sloppy experiment. So again, I'll go over what I'm thinking is the better approach to this experiment. It does eliminate the gravity problem, gets rid of a lot of the problems, and pretty fairly fair to the experiment is the Brozosian idea of just sliding something across glass. So you take some very smooth surface and you take ball bearings or some sort of metal that has very little contact. So it slides really easy because there's so little contact. So I'm thinking of making some sort of platform for ball bearings. I could put 3 ball bearings on it. Maybe that would slide very easily. Ideally, it would just be one contact point, but I haven't figured out the best yet. But that's the idea. So the Brozo did do an experiment, okay, where he had the right spring force, okay, a lever, and frankly, he was doing the right distances. So you probably don't have to really account for the lever, put a 1 mass out here and a 2 mass here, and shoot them with the same force and slide them across a frictionless surface, and you get rid of a lot of the problems with carts, for example. Carts have the problem that part of the motion in a direction is invisible, in the sense that the cart actually has extra energy in the rotation of its wheels. So the heavier its wheels are, made out of metal, for example, and a lot of them, the more motion, the more energy is in the angular momentum of the spinning wheels. And so you don't see it as an actual velocity. So measuring velocity doesn't tell you exactly how much momentum is actually in the object, because there's these extra bits that are spinning that are like little flywheels. They have more energy in them. Alright, and so that sort of makes the carts dangerous, because now you're playing with, as soon as you change the speed, you change how much momentum is trapped in these little wheels. So if I go faster or slower, I'm going to change how much energy is in the wheels without changing how fast the car is going, which just confuses the whole thing. There'll be a relationship between the cart's linear speed and how much energy is stored in the wheels, but again, ideally you don't want that. And then there's the air track example, where the flaw here is that you're shooting a bunch of energy into the experiment. And so if this little cart tips this way, or if it tips that way, it can basically just create an exhaust, like a jet. Okay, it'll have an exhaust and push the little cart because of the extra energy you're supplying to the system. So your velocity in a direction can be distorted by the fact that you are pumping extra energy into the system, and the extra energy can be unbalanced and create distortions in the reality. So these are all things, doing these experiments over and over, that we all learn. So like in the Brozo example, see, if we were to use dropping the object onto the lever, and again, it would be one spot. We have to drop it on the same spot over here. So if we drop a 2 mass over here, the weight of the lever, okay, isn't going to make that much difference, but you have to understand it's making some difference. It's consuming some portion of the momentum. So when you say, well, I'm going to put these at locations that are going to be 2-to-1 locations, you know, here and here, it's really not an ideal lever. So you have to recognize the fact that when you do this experiment, you're automatically going to lose some energy to the lever. So you don't have the expectation that, say, if you have 100 momentums going in here, that you can get 100 out, because you can't. Because some percentage is going to move, some percentage of this energy is going to be used to move this lever. And so you have to compensate for the fact that, okay, if it's only 90%, well, then if I want to try to get twice as much energy into this other object, I'm going to have to fiddle with its location, because it's going to have to be somewhere maybe a little closer, because this is going to make it too heavy. The 90% can't push this at twice the speed, so the lever will move at a different speed because it can't push at twice the speed with less energy. So these are all things you have to be aware of, blah, 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 blah. And drawing them all out does make it easier to understand conceptually what you're after. So let's just understand the Brozo experiment's already been done. It came out, 19 and 11, which are numbers pretty close to 2-to-1. And I'd argue just doing that experiment better likely can fix that to 2-to-1, 20-to-10. Not a problem. So that's probably the experiment I would choose to do eventually if I must, if no one else can manage to do a reasonable experiment in terms of recognizing all of the potential defects, variables that are in all of these experiments. Now, the simple truth is they should just get around to figuring out how to prove, okay, that something going twice as fast has 4 times the energy. That is, that it takes twice as much energy, so 4 times as much energy to make a motor spin twice as fast. And that it takes 9 times as much energy, 9, okay, to make a motor spin 3 times as fast. And it takes 16 times the energy to make a motor spin 4 times as fast. That's the experiment they should really get around to, because, that one will certainly be showing us something that I find impossible to believe actually happens, that there's nothing in my life experience that ever demonstrated this to be true. And certainly you would think the government would be telling people about this incredible way to save an insane amount of fuel by driving slower, a lot slower. The slower you drive, the more you're saving, right? I mean, just do the 10 miles an hour to 20 mile an hour, or 30 mile. Yeah, 10 to 30. I mean, 9 to 4. I mean, you just keeps getting more and more gigantic, the amount of fuel you can save. I mean, to go 10 times as fast, to go 100 miles an hour instead of 10 miles an hour is 100 times the fuel. I mean, that's a lot of fuel. All right. So, I mean, that would be the experiment that really proved this nonsense, but they won't get around to doing those experiments. And certainly they could do some logic experiments in space. I mean, it's been pointed out that, if I am in space and I have a device, and I can, use the device to shoot heavy things, or I can use the device to shoot light things, right? I can decide how big the particles are, and the pressure is going to shoot the little particles. And the fact is that I can't gain anything by shooting the lighter particles. So if I have like a fire extinguisher and I could just make a setting and say shoot big things, shoot little things. Shooting little things won't get me more energy out of the fire extinguisher. I won't get more power because momentum is going to decide, and it's going to have to be conserved. I have to conserve the momentum that's in the pressure in the vessel. And so if I use any kind of thrust to move in space, it's just going to be about calculating the mass of the little particles and their velocity. And that's going to tell me how much energy I gave away. That's going to tell me how much pressure I let out that left me and is now going somewhere else. And that's all that's going to move me, frankly, is that pressure being absent. Yeah. So I could shoot no particles at all, and that is if I just filled it with a some sort of photonic type pressure. I wouldn't have to shoot any matter at all. I could just shoot the photons, because it's really in the end just about the energy that the matter is carrying. So if I give away some kind of, I throw a dime going 1,000 miles an hour out one side of my ship, or I throw 2-liter bottles full of water out the other side, 1,000 difference in the masses. I'm not going to get 1,000 times, even though the dime is traveling 1,000 times faster, it's 1,000 times lighter, and so I'm not going to gain anything. I'm not going to turn my ship doing that. If I do the 10-ton train out one side of my ship going 5 miles an hour and a 5-ton train going 10 out the other side, it's not going to turn the ship. Now, those arguments should be pretty decisive, and kind of, as long as a physicist agrees that that's the truth, then what else is there to argue, right? It should be over, because if you can't use this energy to move something in empty space, then it obviously can't be real energy. All right. But none of that will be addressed. None of that will be argued. And instead, they'll keep trying to contrive experiments to somehow prove, with these weak experiments, that somehow this always wrong theory, this just kind of nonsensical, frankly, theory, they had a perfectly good answer. Galileo, Descartes, and Newton gave them perfectly good theories of reality and predicted and made accurate predictions with those theories. And for some reason, science said, oh, hell with that. Let's do the silly stuff instead. Let's believe something they didn't believe and they didn't get right answers with. Let's believe that instead. And they're making me out to be some sort of criminal, because I merely point out this is still an unevidenced fable. All right. So that's probably enough of this video. And we'll move on to another one. Yeah. So, till the next time and such. But yeah, there's just no, I mean, if these people, really, if they're too stupid to figure out simple logical things, like I don't appreciate you picking on, attacking my neighbors or my family or anybody else living in this house because you don't like what I'm saying. And that's an absolute fact. Those are the people you're threatening, And fuck you for that.